Welcome to this webinar. The topic for today is artificial intelligence in hardness testing and what's all about. To my part, my name is Michael Granditz. I am part of MCOTest since 2012, starting as a product manager. I am now in charge of the whole development team since 5 years now. And in the picture at the bottom right side, you can see where we are located. So we are a smaller company and we are focusing on everything and just hardness testing from the hardware and software side. Okay, I will highlight now a little bit more. So you should now see the presentation in full screen. And we get started with the topic for today, artificial intelligence. So first of all, I may introduce a little bit general what is artificial intelligence, the strongs and the weaks of this technology, which is not that new, but in the last years it's more and more important. And you can divide artificial intelligence into many different aspects and chapters and what you can see on the right side. There are different pictures showing how you can divide the different technologies of artificial intelligence. But basically, I want to break it down to just two of them. And also, there are different definitions out there because it's that brand new. There are different definitions on what is artificial intelligence. The one I like most is basically it's artificial intelligence if it seems that the computer is able to do things which are typically requires human intelligence. So not stupid automation, but something where you think normally it would have been someone behind, and it seems to be there as a human being, but it's not. And then you can divide these artificial intelligence systems in two basic chapters. It's the weak AI, which is designed to handle specific tasks, and strong AI, which is acting like human, which has a real intelligence. And when you have something in mind, now have a picture in mind, what's weak and what's strong. Maybe I have some examples, and you can think about if it's weak or strong. So if you think about something in your smartphone which detects smiling faces or every house or every bird in the picture, that could be something which is weak AI because it's a very basic function. When it comes to automotive driving or automatic driving of cars, could that be strong AI or weak AI? Now that's still weak AI. And when it comes to the most common or most impressive artificial intelligence, something like ChatGPT or picture generators, is this weak AI or strong AI? And the surprising answer is, yeah, that's still weak AI. And strong AI is still, at this very moment, a little bit of science fiction. And what does that mean? Weak AI means it's still not intelligent. It's just a lot of statistic, a lot of intelligence in these systems by human beings introduce all the knowledge into these systems, and quite a lot of data behind this statistic. But also ChatGPT in the very base is not intelligent. It's just a more or less stupid system based on a very, very complicated statistic and a very, very huge base of data. And ChatGPT has learned the whole internet. So that's also the weak point, because now he has learned more or less everything out there which is easily to be accessed. So the improvement of these systems are now decreasing because, yeah, what's next to be learned? And that brings us to what it's good for. So what do you use it for? You take, for instance, this is an artificial intelligence which was designed to know all dogs and bicycles in some pictures. What you do is you find the right model, you train this system with a lot of data, much more than in this picture for sure, and then it will be very easy, it will be able to find very quick and very sure all dogs and bicycles in all pictures you show this AI. So, but there are limits and problems of this AI because it's not really intelligent. It's all about statistics and a lot of data. And what I wanted to highlight, because it's also a little bit maybe funny, but easy to remember, is the baby peacock effect. And in this case, we take, for instance, we take ChatGPT, and you call him and you want him to make a picture of a baby peacock. And what's the database? The database is very huge. You have a lot of pictures out there with peacocks. What you do not have in the internet relatively is baby peacocks. And baby peacocks in the reality looks like that. So quite different. But what the AI systems have learned is how a baby of any animal looks like. And since he does not find real baby peacocks, he draws something which looks like that. And this is what the AI think is a baby peacock. And now all the internet, if you go for a search of pictures of baby peacocks, you will find more artificial intelligence created baby peacocks, so not real ones, than the real ones. And all the new and the next training data for these artificial intelligence systems are now the wrong ones, and they learn that the wrong baby peacock will be the truth. So the quality of the answer is worse than before. So it's learning from the wrong data, which is created by the artificial intelligence itself. And this is a problem or an effect you have to deal with when it comes to artificial intelligence and how to train them. The next thing is hallucinations. The statistic behind so the one thing is the data, the other thing is statistics. And these statistic systems are that complicated that basically no one knows what's really happening inside this system. So it's hard to systematically improve them or do quality inspection or to guarantee the quality of the outcome. And what I have as a sample is my try to create a logo for our artificial intelligence systems, which we call ACOS AI. And I asked in this case ChatGPT, make me a cool logo which combines our ACOS AI naming with a certain some artificial intelligence, and it came out with that, which was quite satisfying for me. But our ACOS logo looks a little bit different, so it has a red E, and so it's a little bit from our company graphics. It's a little bit different, and I told him, please make me just the E in red, and he did it, but without this AI branding. And I wanted to have it back, and he gave it with that. So it was not satisfying, and not even that satisfying that the first one. And I give that some other tries, and it went worse to worse from every approach. At the end of the day, it was not even our naming in that. So the final logo was, the idea came from ChatGPT a little bit, but the final logo was made by a human being in our case. So this is a little background knowledge of artificial intelligence and what you have to have in mind if you make something like that for a testing system where creativity and uncertainty is absolutely not what you want to have. You want to have a stable system which is used for quality control with a stable quality. So now we are going from the general world of artificial intelligence, which everyone maybe of us uses from day to day, to what we have in the hardness testing. And we want to assist everyone which is working with a hardness tester by the use of an AI-based system. But which problem do we want to solve? Let's get back a little bit in history. Hardness testing and Vickers, Snoop, Brinell these methods are around 100 years old, and in those days there was whether an artificial intelligence nor computer system or camera system. So everything was about a microscope looking onto your indent, which was made with a mechanical system, and then some operator which is measuring the diagonals of the indent with some mechanical device inside the optical system. And this requires very careful operation by the worker. It's time consuming in comparison which we have now with the computer. And of course, you have deviation between operators and also with one operators from the one day or to the other. In the early 2000s, the first fully automated hardness testers were introduced. And fully automated hardness testing is possible not just because we have automated XY stages, but also you need for sure something which evaluates the indent automatically. And with the first camera systems and computer systems, it was able to make a picture of the indent, and with the classical segmentation algorithm, it was possible to detect the diameter of the indents automatically. This is for sure mandatory for fully automated hardness testers, but also used for all the other hardness testers. The benefit was it eliminates user influence and speeds up increases the efficiency when you do hardness testing. And this segmentation algorithms were improved over the years, so now they are far better than in the early 2000s, and they work well in the most cases and are still, or at this very moment, state of the art when it comes to high quality or premium hardness tester. But what it works, yeah, basically on most surfaces, but they are developed for 20 years, and at the moment there are no further significant improvements to be expected when you use standard algorithms. And this was also for us a pain from the last 10 years because it worked. We had so we got the feedback also from customers that our algorithms for these tasks are working quite well in comparison to others, and it's nice to work, and normally you do not have any problems. But you have cases where you have problems, and we do not have an idea, or we did not have an idea how to improve that standard algorithm. And what is the problem? The problem is if you have difficult surfaces combined with a high amount of indents, the result of these old algorithms is not satisfying. So we want to have an automated image and indent detection. Also on weak surfaces, coatings, etched surfaces, powder metal, something like that. And that's where we introduced the AQUS AI, which is standard for AQUS 3 since last year. So AQUS 3 was introduced last summer, and AQUS AI is a standard part of that. So you will never know, or you will not, it's transparent for the user, so you will not get this information, but it just works better than before. And the step is impressive. And what does it do? The AQUS AI is a part of the image analysis system. So a normal camera system takes the image of the indent, then the image is analyzed by the artificial intelligence and analyzed and then measured. So you get the same result picture than before, but just in between there is AQUS AI, which works more or less like a human operator recognizing the indent and measuring it. And the result is we have not just a step-by-step incremental performance improvement of that, but it's in this very aspect, it's revolutionizing, because with one change of technology, we get 80% better than before, where it was just better some percentages over the years from the early 2000s to now. With standard approach, we have a huge step forward. And it's just the beginning. Now we are starting the incremental improvement as well. But how to get there? So now we have it and it works and it's impressive. But I just want to tell you a little bit of the technology behind and the tasks and the challenges we have had in before. The good thing is we can develop this system in-house in the team of ZwickRoell. So we have specialists for artificial intelligence helping us to adapt this to hardness testing. So the knowledge of all I'm telling you now is in our house. And these are just some steps you have to do. You have to find the perfect machine learning model. What we do here is machine learning. And there are a lot of different state-of-the-art models which can be used, but you have to find the right one. And it's not always the same for different methods. The next thing is you have to define the correct parameter set which these models can be operated with. And also that's a lot of trial and error combined with a lot of non-knowledge of the background system. And the next thing is, so now you have your basic rule set, and now you have to do a lot of work because you have to create the training data. As I said before, ChatGPT, for instance, have learned the whole internet to be that impressive as it is now. When it comes to hardness testing images, you have to do this work by your very own. So you have to collect different thousands of pictures on different surfaces, which you want to be evaluated later on. And then you have to mark all these indents manually on the surface. And this is a work which is for sure boring, but you have to do it with passion in order to keep the quality as high as possible. And we did thousands of manual pictures, which can then be expanded due to some smart algorithms to some millions of pictures. And then you get the training session with your model, which you decided before. And then you train this AI-based system or this AI system and the AI model on a very, very strong and powerful computer system. This is what you hear in maybe in the news, where NVIDIA sells tons of graphic cards. These are these strong systems which are needed to train the artificial intelligence system or the model onto your data. And then if you have this model which is running and can be tested, you have to integrate it to an operating software which can be used by an operator. So you have to make it more efficient when it comes to computing power, and you have to integrate it into an operating software, hardness operating software, where it can be used and gives the right quality of the result. And when it comes to quality, how to ensure that this artificial intelligence based system gives you the correct result in comparison to what you have done before. And as I said before, so what we do not want to have is something like the baby peacock or effect, or some system which is hallucinating, and you want to have a perfect working measurement system, not something which get creative by itself. And the first thing, you can do some tests and compare the systems you know already. So we did a lot of tests with real indents and compare ACOS AI with some human beings, because what we want to achieve is the same quality than a human being would create. And what you can see on the left diagram is the preciseness comparison between ACOS AI and some human operator. And all these images, which are completely the same, so the measurement line is drawn at the very same pixel in both sides, is the first column. The second column is where it's just 1 pixel away, the next one just 2 pixels away. And you see that they are very close together in most cases, between 1 pixel deviation. On the right-hand side, it's the same, but we compare ACOS AI with our, old classical algorithm, which is on the market for 20 years, improved over years, and we know that it's working good. And you can see that it's quite equal to the human, but even more precise. So what you can say here is ACOS AI is as precise as anyone else. And if you compare it, the two machine-based, so that the two digital versions, they are closer together, which means that an computer analyzed indent is always better, and the result is more stable than if you do it manually. So the quality of the data is better if you do it automatically in comparison to do it manually. Not a big surprise, but this data proves it. So this is the first check you can do to get sure that the ACOS AI is as good as a human being or our classical algorithm we had before. The next thing we did, because to get really sure, we did a field test. And we introduced the first model in 2022 with our existing software with ACOS Workflow, and did a test run with some customers out there for over 1 or 2 years. Some of them are running till now, to get sure that the quality is as good as we think it is. And the result, yes, it is. So absolutely no problems regarding preciseness. It's as good as before, but the hit rate of indents on very bad surfaces is far away better. So how is ACOS AI working? Now I told you how it was trained, how it was quality checked, and how we came to the point where we are now. And the point where we are now is shown in this slide. So ACOS AI is working very efficiently on any standard PC. So as I said before, it's trained on a very, very powerful PC, but it's working on any standard PC. So we're speaking about a state-of-the-art i3 or a standard i5 with standard equipment. So nothing very powerful needed. The next thing is there is no internet connection required, because the training is done with our pictures on in our powerful PC system, and then the model knows all that. That also means that there is no data sent or shared which is generated on your hardness testers. And there is no improvement by itself when it's running. So that means no baby peacock effect and no hallucination. It's a stable system which is quality checked and proved and implemented into ACOS 3. It may be improved with the next updates of ACOS 3, but when it's running on your system, it's always the same. There is no automated learning on your PC. And that's absolutely mandatory when it comes to a measurement system, because we do not want to have a self-learning system which runs away and gets hallucinating. And that guarantees your consistent test results. So we have under control what the AI is doing because it's stable and always the same. Now I have some result data for you to show. For instance, I did a test with 100 measurement on a very bad surface, just to get an idea on how good we get. And our classical model, which is still one of the best out there, got a hit rate of 56. So we got 56 incorrect measured indents out of these 100. And we did the same pictures with the machine learning algorithm, and we came out that just 10 of them were not recognized perfectly, and most of them are really hard to manually remeasure because it's hard to see where the indent really is. And when you keep in mind that one manual remeasurement now takes you about 15 seconds to be performed and additionally adds a little bit of uncertainty, so the quality is not that good with an compared to an automated or automatic generated analyze. That's something you have to keep in mind. Also some pictures as an example. The left-hand side is the old algorithm. On the right-hand side, you see the correct, the machine learning version. Here you can see segmentation looks about when it goes from dark to bright. And since there is a dark spot on the left side, it detects this spot as a part of the indent. And on the right-hand side, machine learning knows the shape of the indent and ignores the spot because the spot is not shaped like the indent, and works like a human operator. And also on this one, where it's also could be a little bit tough for a human being to evaluate the top tip, and the machine learning, I think, does the same that I would do on this picture. Now I want to show you a more practical sample, because as I said, it's very good on very bad surfaces. So the benefit of the new artificial intelligence based algorithm is as better as worse the surface gets. And when it comes to welds, you have to etch the surface in order to see the different zones of a weld and to do the hardness testing as it's supposed to be. And what means etching gets the surface worse, making it harder to get a good indent evaluation. So in this case, it's something you have to deal with. And what you can see here, this is a picture taken with the overview camera of our DuraScan micro hardness tester, where you can see the etched zones. In this case, I did a panorama picture with a microscope lens to even get better quality, and you can see the heavy etching on this weld. And I tried to make a welding test sample using our welding tool, where you can draw the different zones, and I did the indents. What you can see here, this is how the indents are looking on this etched base material, and all the indents were covered perfectly by Aqueous AI. This is a picture of the heat affected zone and the base material, and you can see the sample was not brand new. There is a little bit oxidation, but it does not have any problem, or we do not have any problem with recognizing the indent perfectly. And this is the result without any manual interaction. We get a perfect result. And what I did the same on a not on the very same sample, but on a similar prepared one. And we made a mapping. So we created an overview of the surface of a etched weld with about 2,000, or not about, with 2,144 test points to create a real good resolution. And I got just 16 not evaluated indents, and it took me just 4 minutes to fix it. The mapping itself ran for, I think, nearly 2 days, and it just was 4 minutes work to get it perfectly done. And this is a very good result if you have in mind this is not a perfect surface, this is an etched sample. So the benefits get very bad. The benefits you have from ACOS AI is far away better if you have poor surfaces like dark coatings, corroded corroded surfaces, etched surfaces. If you have normal sample preparation and your sample preparation is not perfect, it will be more safe if you use ACOS AI, and even on test blocks. Yeah, on test blocks, you do not have any problems with the old fashioned algorithm. And if you do not have a problem, then ACOS AI will not fix a problem you do not have. So basically, as an operator, you will not see ACOS AI, but you will see the result on worse on poor surfaces. So as a final summarize, we can say, or just again what I said before, ACOS AI is a standard feature of ACOS 3. You do not have to pay it additionally. You will not see it inside. You will just get the benefit of the better reading of any result. It works for Vickers, Snoop, and Brinell indents, and we test all these since 3 years now. It's working on any standard PC, which covers our minimum PC requirements, which are quite common. You will not need any internet connection during setup or operating the machine. And of course, there is no data shared. It's absolute transparent for the user. As I said before, you will not know that it's working, but you will get the better results. We improve and quality test this system continuously. So we got now a huge step forward when it comes to automated indent recognition. And now we start the step-by-step improvement by just improving the models, improving the data set, and of course, creating more and more training data. And last but not least, it does not learn by itself. So it's intelligent. It seems to be intelligent, as stupid as any other artificial intelligence system. But since it's not being trained on your PC, but just executed what it has learned in our very strong PC, and then going through a very sophisticated quality improvement system, you get sure that you have a stable system which is consistent in its results, and to guarantee stable test results. If you have any questions in the future, please do not hesitate to contact us. We have or our application engineers. Thank you very much and have a nice day. Goodbye.